Welcome to the DIY Honda Garage channel. The DTC P16E3 indicates a communication error between the Powertrain Control Module (PCM) and the 12-volt battery sensor over the local interconnect network (LIN). The PCM requires accurate sensor data for effective vehicle operation, particularly for managing battery usage and ensuring reliable engine performance. The 12-volt battery sensor plays a vital role by monitoring the battery state and communicating critical information to the PCM. When there is a disruption in this communication, the PCM triggers the P16E3 error code to alert the technician of potential underlying issues. This could be due to faulty wiring, a malfunctioning battery sensor, or problems within the PCM itself. Identifying the root cause through thorough troubleshooting is essential to restore normal vehicle functionality. DTC P16E3 refers specifically to the diagnostic trouble code indicating a LIN communication error between the PCM and the 12-volt battery sensor. The key components affected by this error include the PCM, which houses the vehicle's engine control operations, the 12-volt battery sensor that monitors and relays battery status, the DC-DC converter, and valuable components like the alternator and shutter grille. The 12-volt battery sensor is typically located near the vehicle's battery, fastened securely to the battery terminal, making it accessible for inspection. The PCM can generally be found within the engine bay or under the dashboard, depending on the model and configuration of the vehicle. A clear understanding of these components' roles and locations helps facilitate more effective troubleshooting. Several potential causes could lead to the occurrence of DTC P16E3. One common issue is loose terminals on the 12-volt battery sensor, which can disrupt the communication required for normal operation. If the connections are not secure, the PCM may fail to receive accurate signals, thereby triggering this error code. Additionally, a faulty 12-volt battery sensor itself could be to blame, as this component is crucial for accurately measuring battery status and needs to function optimally to prevent errors. Furthermore, a disruption in communication within the PCM, which could stem from short circuits or other electrical issues in the LIN, local interconnect network, can also contribute to this error. Understanding these underlying causes lays a strong foundation for effective diagnostics. Several symptoms could potentially indicate the presence of DTC P16E3. First, warning lights on the dashboard may illuminate, signaling that the vehicle system has detected a fault, specifically involving the battery sensor. This often serves as the operator's first warning of underlying issues. Additionally, drivers may experience battery charge problems, noticing that the vehicle's battery isn't powering systems effectively or is discharging more rapidly than normal. Another significant symptom could be engine performance issues. Erratic engine behavior may occur due to the PCM not receiving correct data related to battery voltage and health. These symptoms are crucial indicators that warrant immediate troubleshooting efforts to diagnose and resolve the underlying problems. In the initial step of troubleshooting DTC P16E3, start by checking the terminals on the 12-volt battery sensor. Loose connections are often a straightforward issue that can easily disrupt communication with the PCM. Ensure that the negative terminal and sensor connections are secure. Next, inspect the LIN communication lines for potential damage or disconnections. This can include checking for frays, shorts, or breaks in the wiring that could interfere with proper data transmission. Finally, assess the PCM's error status by confirming whether any additional diagnostic trouble codes are present alongside P16E3. This comprehensive first step is critical to rule out simple faults that are quick and easy to remedy. Following the preliminary checks, the next step involves conducting a test on the 12-volt battery sensor. This sensor is pivotal for communicating battery status back to the PCM, and any failures here could directly contribute to DTC P16E3. After confirming that the sensor is working, verify the health of the battery itself. An underperforming battery can send erroneous signals or fall short of power needs, affecting overall vehicle functionality. Additionally, inspect the wiring connected to both the sensor and the PCM for any potential shorts or breaks. This systematic approach helps confirm that these essential components are functioning correctly and eliminates some of the more common failure points. The next troubleshooting step requires conducting a thorough PCM check. If previous inspections revealed no faults in the battery sensor or its wiring, it's time to focus on the PCM itself. Begin by inspecting the PCM's input and output connections for integrity and security. Loose or corroded terminals can severely impact communication and operational efficiency. If corrosion is detected on these connections, it needs to be addressed to ensure proper function. Additionally, if available, utilize diagnostic tools to assess the PCM for any reported faults or malfunctions. By scrutinizing this critical module, technicians can identify if the PCM is at fault, thereby addressing the root cause of the P16E3 error. Once repairs have been completed, it's essential to perform a final verification to ensure that the P16E3 error has been resolved successfully. Start by clearing the diagnostic trouble codes from the PCM. Then, take the vehicle for a test drive under various scenarios to confirm the effectiveness of the repairs. During the drive, actively monitor the system behaviors to check for any recurrence of warning lights or issues related to battery monitoring. If the error code does not appear again and systems are functioning as expected, it indicates a successful resolution. Always remember to keep a detailed log of repairs and findings for future reference. Preventive maintenance plays a critical role in minimizing the risk of DTC P16E3 reoccurring in the future. Begin by regularly inspecting the battery terminals to ensure that they are secure and free from corrosion. Any signs of corrosion should be addressed promptly to prevent electrical issues down the line. Next, frequently check all wiring associated with the 12-volt battery sensor and the PCM for any signs of wear, damage, or fraying. Maintaining clean and tight connections cannot be overstated, as secure contacts prevent communication errors. Implementing these preventive measures can help significantly extend the lifespan of critical components and reduce unscheduled repairs. In conclusion, understanding DTC P16E3 and its implications is crucial for maintaining the long-term reliability of the Honda CR-V. Following a systematic troubleshooting approach is vital in diagnosing the root cause effectively. Each component involved, the PCM, 12-volt battery sensor, and LIN communication, plays a significant role, and diligence in inspection can prevent further complications. Regular maintenance is equally important. Proactive checks on battery terminals and wiring can help avert issues before they arise. By keeping the vehicle in good condition and performing timely repairs, drivers can maximize performance and minimize the likelihood of experiencing DTC P16E3 again in the future. Please like and subscribe to the channel. See you next time.